Okay, while I have a little bit of room and have this graph on the board, I'm going to construct something I call a slope graph, okay? And I'm going to construct that down here. Slope graph has slope versus x. Now, what could that possibly mean? Well, a little more in detail. I mean the slope of the tangent line versus the x-coordinate of the point of tangency. So, I've marked 4 points on this graph, and I want to draw a tangent line at each of those points. So a tangent line is a line that just touches the graph in one point. So there's a tangent line at this first point. Now I can draw another tangent line at the second point, and it's going to kind of intersect with the tangent line from the first point. That doesn't hurt anything. Okay, so there's a tangent line to the second point. So we have a tangent line here and a tangent line here. Now I'm going to kind of be in the way even more than I was before as I draw a couple more tangent lines. So I'll try to do that quickly so you can see the result. Okay, there's a tangent line, a line that's tangent at this point and a line that's tangent at this point. Now this isn't perfect. I really think the point of tangency for this line, if I accept the curve, is more like here than it is here. But we'll still be able to see what's going on. Now we want the slope of the tangent line, and we should know what the slope is. You should stop and think for a minute. What's the definition of a slope? Okay, well, I've had people say, like, y2 minus y1 over x2 minus x1. That's pretty good. There's a simpler definition, though. It's simply what? What do you think of? What are the first words you think of when you hear the word slope? Well, if you've done much at all with slopes, you know that slope is rise divided by run. The slope of a graph is its rise divided by its run. So what I want to do is I want to construct, and I'm not actually going to construct these geometrically, but I'm just going to draw them with a straight edge, a series of triangles, okay? This triangle represents the slope of the first tangent line. Okay, the rise of this triangle divided by the run of the triangle will be the slope of the tangent line, assuming that the graph has gone from one point of the tangent line to the other. And I tried to make it that way, and I think I was relatively successful. Now, I want to draw a tangent line, or a triangle representing the slope of the tangent line to the second point. And to do that, I want to be able to directly compare the slope of the first graph to the slope of the second. So I want my run to be the same as it was on the first graph, and then I can simply compare the rises to see how the slopes compare. In other words, if the run is the same, then if the rise here is twice as great as the rise here, then it follows that the slope is going to be twice as big, because I'd be dividing the rise by the same run in both cases. Now again, I want to try to use the same run for every case, so I want to bring my, and actually I'm going to draw the horizontal leg of the triangle here. It doesn't matter whether I draw the horizontal leg above or below the line that I'm trying to do the tangent of. So I'm going to do this one below. Okay, and then over here I'm going to do the same thing. And to get a run equal to the run of this first triangle, I'm going to have to extend this tangent line a bit. I'm going to have to extend it way over to about here. So I'm not going to bother with a straight edge, but I'll try to keep it as straight as possible. Okay, so this tangent line is going to give us a slope represented by this triangle. And I used the wrong color. I've been using green for the legs of the triangle, so let me more or less fix that. Okay, so now I've got 4 triangles, all with about the same run. I wasn't real careful about that. And of course, you can construct that. You can construct that with a lot of accuracy. Then, I can check this out. Okay. The rise of this triangle is represented by this distance. Now, if I do that distance and then do it again, it looks like the rise of this triangle is about double the rise of this triangle. Now, what's the rise of this triangle? I can do that with the... Okay, well, it looks like, okay, I've got this, and I've got this. Things are sliding around a bit. Looks like this rise doubles this one. And then, maybe, let's see, this rise looks to about double this one. So, it appears that the slope of each tangent line is about double the slope of the previous. Now, I didn't really select my points in such a way that I thought that should happen, but and by my construction it appears that it sort of does. Now, you refine the construction. I doubt if you would find that these things exactly double if you do a very good construction of your graph. But in any case, right there we have slopes doubling, and the x values the x value at the point of tangency here is about this. So I'm going to say, okay, I'm going to put a point here. No, wait a minute. That's not right. That's a point that I used in constructing the graph. The point of tangency is here. So my x value would be about here, and I'm going to put a point here. And I'm going to try to get rid of this point here. That looks like I got it. Okay. So there's an x value. Now I move over. The point of tangency was at the y-axis, so that's at x equals 0. And now I've doubled my x value. So it looks like I owe the graph a point that's right about here. Okay, then I move over this far, and it looks like things have doubled again. Well, it's not that high. Double this, we get something like this. And then I move over this much further, and it looks like the slope has doubled again. Now what I've got here is not a graph of the original function, but a graph of the slopes. And the distances between these points of tangency are not, in the first place, not consistent. The changes in the x value are not always the same, but they don't match the doubling displacement either. So this graph appears to be related to this graph, but we can't draw a lot of conclusions. Okay, because of the construction and the approximate nature of what I'm doing, it looks like this graph should be exponential. And it looks like just coincidentally I picked points at a distance that give us another kind of a doubling displacement that's not equal to the first. There are all kinds of questions around that I don't want to get into right now, but I guess we ask the question is this slope graph exponential if it's constructed accurately? So is it exponential? If so, are the doubling displacements equal? And maybe, if not, just what kind of graph is this? Could this possibly be a power function graph?